This is page 9 of slide 6.2.1.4. In this slide, we are asking about the periodic nature of xn and ck. In all the equations of the analysis, this equation here as well as the synthesis, this is equation here, notice that we often only talk about 0 to n minus 1 for the synthesis, as well as analysis k equals to 0 to n minus 1. Why is this so? What happened when we plug in, for example, when we are interested to find from x capital N to 2n, or x capital 3n to 4n minus 1, and so on. So this the next period of xn for period, since xn given to us is periodic, do we get the same answer as from index 0 to n minus 1? So let us try to analyze it from this range. Remember that we are in discrete time, therefore small little n is an integer and k is also an integer. So in fact, this is the real reason why the exponential j2 pi k over n times n is n sample periodic. Let's begin. Let's write the analysis equation, and this time we are going to examine the next period, which is from big N to 2n minus 1. So this index here will range from capital N to 2n minus 1. Let's examine this equation here. When we examine from big N, we can write it as, let's say for example, n plus maybe q, where q will be from 0 to n minus 1. So this is trying to say that we're going to start from n, and we add a little small value of from 0 to n minus 1 to satisfy this range. And we can now break the exponential up into two parts. The first part is using k and big N, and the second part is using k and q. Notice that this part, capital N, can be reduced, and now we are left with ej2 pi k, and remember k is integer, so therefore this is j times 2 pi, any value of k, 1 or 2 will become j2 pi, 4 pi minus 2 pi, and this is the same as value 1, and therefore the synthesis equation now is only dependent on this. And therefore, isn't this the equation that we had for the original synthesis equation from range of index n equals to 0 to n minus 1? So this is the reason why in analysis we're only interested in 0 to n minus 1. Not because there's no other values outside, but if we substitute the next range of value, we're getting actually back to the same principal range from 0 to n minus 1. And if you actually analyze the same problem for ck, then you'll realize that the argument is the same. It is because of this, the nature of this equation, which reduces to 1 when we do index from k equals to big N to n minus 1. So that's all we have. Thank you.